This is the case of aortopulmonary window defect. This is parasternal short axis view. In this image you can see the structure. This is left atrium, right ventricle, pulmonary artery, A for aorta and P for pulmonary artery. This is window. This is right pulmonary artery branch. So what you see, there is defect between aorta and pulmonary artery that creates window. That window means flow is communicating between aorta and pulmonary artery. Naturally, during the development process, aorta and pulmonary artery get separated by a wall between these two structures. During development process, that wall gets defective and that results into window. So what you see in this image, aorta takes separate origin, pulmonary artery also takes separate origin. But in continuation, then there is defect between aorta and pulmonary artery. Main pulmonary artery you say, a pulmonary trunk you say. So that defect is called aortopulmonary window. Window happens before the division of right and left pulmonary, before the main pulmonary divides into right and left pulmonary artery. So this defect is aortopulmonary window. Finding wise, what will happen? Just like PDA, LA and LV enlarged, flow reversal in descending abdominal aorta, or abdominal aorta, you can see. But in this case is slightly different because the patient is 3.5 months old infant and has developed significant pulmonary artery hypertension. See again. This is aorta and this is pulmonary artery. If you move the image, you will see then defect comes. You see that this is defect. This is defect. Aortopulmonary window defect. So you have to be very much suspicious of this finding because echo drop rate is also there in some cases, but this is definitely because one way also to understand when there is defect, you can see the margin little bit more echogenic. This portion is more echogenic. You can see this portion is more echogenic and this portion is more echogenic. If it had been a echo dropout, in that case that will not be the finding. More echogenic end portion is not the finding when there is echo dropout. Either in apical fourth chamber view, ST like dropout you will say that is dropout. In that case of dropout, you will not find the echogenic margin. So whenever you find echogenic margin, that means there is defect, definite defect or true defect you say. Again you see the same thing. Aortopulmonary window. This is window. This is window. There is PFO also. As the pressure on both sides, that means pressure within pulmonary artery and within aorta almost equal. So no significant flow happens between these two structures, aorta to pulmonary artery. You can say bidirectional flow. We can say D-shaped heart, D-shaped left ventricle indicating raised right ventricle systolic pressure. That means significant pulmonary artery hypertension. You can see D-shaped left ventricle. This left ventricle is D-shaped. You see this D-shaped left ventricle. This is D-shaped. D-shaped left ventricle. So D-shaped left ventricle indicates raised right ventricular systolic pressure. If right ventricular systole has become more almost equal to that of systemic pressure, that means pressure of that of aorta, then there will be no flow between pulmonary artery and aorta, or you can say minimum flow, minimum velocity. So we cannot check that velocity at this much scale, because usually take a scale of 60, 70, 80 centimeter per second, but when the velocity is very less velocity, like 5 centimeter per second, 10 centimeter per second, that cannot be detected with that much scale. So you have to reduce the velocity, but you will get lots of turbulence. Finally you cannot find out. But thing that we want to emphasize in this video, LV is D-shaped, indicating raised right ventricular systolic pressure, raised pulmonary artery pressure, that means significant pulmonary artery hypertension, and pressure within pulmonary circulation and aortic circulation are almost equal or close to each other, then there will be almost very minimum flow or no flow. That is why we cannot detect it by Doppler image. So you have to be clear, careful about 2D image. Only 2D image will help you to find out the defect. You have to put a window. Again, window, just show you again same thing. Window, aortopulmonary window. You don't find much flow through window. So whenever the pressure on right and left equal, then you have to be very cautious regarding defect, because defect will not have any flow. So on color Doppler you will not find any flow. Then you will miss if you don't properly focus 2D image. This is PFO. This is PFO. Pattern formable. Here you can see this is the portion where the PFO is expected. Where you see here the two septum, primum and secondum septum, they meet together. This portion has PFO. You can see the mild TR, but the RBSP is very much high. RBSP minus right atrium pressure is 83 millimeter of mercury, and velocity of TRZ, peak velocity of TRZ, 4.5 meter per second. Very high velocity, very high pulmonary artery hypertension. Because whenever RBSP is raised, if there is no pulmonary stenosis, that indicates the raised pulmonary artery pressure also. Same thing. What RBSP means? Pulmonary artery pressure. If there is no pulmonary stenosis. So RBSP minus RES 83 millimeter mercury. So RBSP equal to 83 millimeter mercury plus right atrial pressure. If you add right atrial pressure 10 to 15, then it will become even more than 95. So severe pulmonary artery hypertension is the finding in this case. So ultimately, what we have come to know, when the pressure on both sides equal, either right ventricle or left ventricle, then you have to be careful about regarding BST, because BST cannot be found by Doppler image. Similarly, in case of PDA, if pressure in pulmonary artery and aorta almost same, then there will be almost no significant flow, then you will miss by Doppler finding, color Doppler finding. Similarly, in case of aortopulmonary window, if you do not concentrate on 2D image, then you will miss by Doppler finding, because pressure on both sides equal, flow is minimum. You cannot find it simply by looking at color Doppler image. This is the case of aortopulmonary window. Clear cut case of aortopulmonary window. Thank you.